Hello everyone, today we are going to discuss the low-level design of a web page visits counter. In any low-level design interview, this question can be asked in different forms. For example, you may be asked to design a hit counter, or you may be asked to design basically a counter for counting the likes and retweets of a Twitter post, or counter for counting likes in an Instagram post or views on a YouTube video. So basically you got the gist. There is going to be an entity which can be something like your Facebook post, Twitter post or a YouTube video, and then you will be asked to design a counter for one of the properties which can be views or number of likes or number of shares, something like that. So let's go through the question. This is question number 6 from CodeZym. I have already given the link for it. You can go through and read the whole question. So basically there is going to be a website with n web pages, and pages will be numbered 0 to n minus 1, and our code will be tested in a multi-threaded environment. Now these are the methods which we need to implement. The first one is init. It is sort of our constructor. We will be given total number of pages, which is n. 0 to, so the pages will be numbered 0 to total pages minus 1. We will need the helper just for debugging. You can use helper.print and helper.println methods because system.out.println logs will not be visible. Next, these are the core methods. The first one is increment widget count and the next one is get widget count. So whenever increment widget count is called, you will increment the widget count for that page index by 1, and you will, in case get widget count is called, you will just return the widget count for that page index. Now you will initialize the collection of all the widget counts or that data structure which keeps this collection inside the init method, because it treats it sort of your constructor. Since we are working in a multi-threaded environment, these two methods, increment widget count and get widget count, are not going to be called concurrently by any test case, because this is a write operation for the same page index, this is a write operation on the same field, and this is a read operation on the same field. And we do not want these to conflict for the same page index, else our system will become in inconsistent state temporarily, and we will not be able to properly test it. So to maintain consistency, these two methods will not be called concurrently for the same page index. Now let's go see the different approaches which will be used for solving this question. So we have two simple methods, and we have just to do either an increment widget count or a get widget count. So let's start with a simple solution. Why not use an array list of integers to keep all the widget counts? We have pages which are numbered from 0 to total pages minus 1. So what we do is we get an array list and we initialize for all the total pages, add 0 for it, and then when our increment widget count method is called, what we do is we set that particular page index 1 plus existing widget count, and all widget counts have been initialized with 0. For the get, we simply read from that array list and return it. So this code looks fine and it should work, right? Let's give it a try. So here we go. Now let's try this. Let's see if this code runs correctly. Scroll slightly down. Now our code has completed execution and it took 23 seconds. But you can see there is an error. Our code returned 13969, but it was supposed to return 13989. So it's 20 less. So why is it? Our code is simple and there seems to be no error. The reason for this error is, see this write. It's actually two statements. It's not an atomic statement. First, it reads the existing value from the widget counts array list. This array list widget counts, and then it updates the existing page index of that array list that is add once to the existing count. So it's actually two methods. So this will work correctly in a single threaded environment, but in a multi-threaded environment this will be wrong, because what will happen, thread A and thread B, let's suppose, both will compete. Let's suppose thread A comes, sees that the existing value is 5. At the same time thread B comes and sees that existing value is 5 for the same page index, and then both will increment and final value will be 6. but actually final value should have been 7. So that is what is happening. So actually this code which looks correct is not correct. So we see that a solution which would work fine in a single threaded environment may fail in a multi-threaded environment. So what we can do to remedy it? We can use the synchronized keyword. So basically what we can do is we can use the synchronized keyword to lock this widget counts array list whenever we are updating any item in it. So basically we are converting a multi-threaded environment to a single threaded environment only for this write operation, and this is basically you can say this is a mutable shared state, this widget counts array list, which is basically updated by multiple threads at a time. So let's go see that our code runs. So paste it here and comment out this helper code and let's see how it goes. Let's hit the run button. All our sample test cases have passed. Now why not let's go and submit and see that it passes all the test cases. All of our test cases have passed. It took 28 seconds. So indeed, using synchronized keyword to lock this widget counts array list is a correct approach, but that's what also makes it an inefficient approach, because at a time only one thread is able to write to this list, and so in a multi-threaded environment we are losing the benefit of our multiple processors in our local machine or cloud machine. Rest all the hardware is sitting idle. So what we want ideally is we want as many threads as possible to write to this array list or whatever collection we are using. So why not go? Let's see a better data structure. Using an array list of integers to keep all the widget counts is correct whenever we use locking with synchronized keyword, but it is not the most efficient. It allows only one thread to update the values in the list. We can use a concurrent hash map which allows multiple threads to add updates to this data structure. So we can set the concurrency here to 2 threads or 4 threads or 8 threads. It takes more space as compared to an array list of integers, but then it makes that up in case of or increases the performance. So it is more beneficial to use in a multi-threaded environment. Let's go through the code. Just like an array list, we initialize with a page index and 0 for the initial count. Whenever we are incrementing, we compute the page index and old value to a old value plus 1, and for getting the widget counts we simply do a get. Let's run the code and this should pass all the test cases. All our sample test cases passed. Let's try the submit and see if it passes everything, all other test cases. It passed all the test cases. So using a concurrent hash map is both in a multi-threaded environment is both correct and more efficient as compared to an array list of integers with synchronized keyword. But can we do even better? Can we increase this parallelism without increasing our memory footprint too much? So let's go see another data structure which is even better for this question. Another way to solve this question efficiently is using an array list of atomic integers. So remember when we used array list in our first solution, we were storing the values in integer. So we actually had to use the synchronized keyword to lock the whole array list of page widget counts. But since we are using an atomic integer here to store the widget counts, so each value can be updated separately by a different thread, because atomic integer is thread safe, it's in itself. So this array list collection is basically used just for reading, and writes will be done to this atomic integer variable. So see the code here. In the init method, we are initializing same as we are doing in the first solution. We are adding an atomic integer with value 0 for each page. And then in increment, what we do is we just get the atomic integer for that page index and do an increment and get operation on it, which is an atomic operation in case of an atomic integer. And we are not, you do not have to use a synchronized lock here. And in get, it's simply you get the atomic integer and do dot get to return the integer value of it. Now the one benefit, a small benefit, is that your memory footprint will be much lesser than using a concurrent hash map. The major performance boost is that now your parallelism has become equal to the total pages. That is, if there are n web pages, then n parallel threads can update those, and this is without any significant increase in the memory footprint. So this is by far the most efficient and the best solution. And since atomic integer doesn't internally use synchronize, it uses compare and set. So it is actually more efficient, because in a synchronized, as we see in the first solution, only one thread can do the write, rest all threads wait. So overall this is a more efficient solution. Let's go run it. The sample test cases have passed. Let's submit and let's see that it passes all the test cases. All our test cases have passed. So this is actually by far the best solution that we have. Now what I will do is I will put all the 3 solutions that we discussed in a blog and put the link to that blog in the description section of this video and also in the comment section. This is an easy question overall, but it gives you the taste of basic data structures which you wish to use in a multi-threaded environment, or which you generally use whenever you are doing low-level design questions. So this is an ideal question to start your low-level design interview preparation. This is all from me today, and I wish you the best of luck for your interview preparation, and hope you get a much better compensation or a much higher compensation than whatever you are making now. Best of luck. Thank you.